Mercury is only slightly larger than the Moon. Mercury is 20 times smaller than Earth and the smallest planet in the solar system. Mercury is the closest planet to the Sun, orbiting at just 0.4 astronomical unit distance, or 0.4 times Earth's distance to the Sun. Mercury, despite being very close to our star, has a surface temperature average of 356 degrees Fahrenheit. Venus is the owner of this one because its dense atmosphere creates an intense greenhouse effect on Mercury's surface, which has a very thin atmosphere. Our star would be 3 times bigger in the sky if the light from the Sun was 7 times brighter. Mercury, with its 29 miles per hour speed, is the fastest planet in the solar system. It takes 88 days for Mercury to complete one orbit around the Sun. A messenger had taken exotic photos of bright deposits in the bottoms of some craters during Messenger's flyby before orbit. The new photos, which have a resolution of up to 10 yards per pixel, revealed groups of cavities in these locations. These cavities range from a few hundred meters to several miles. The formations can be surrounded by halos made of highly reflective materials, which are typically rocks that have been ejected during the cratering. These bright and new formations have never been seen on another planet or moon of the solar system. These depressions have no known origins. Their appearance, which appears to be the result of etching, indicates that they were created by removing material from the surface. According to one theory, these depressions are caused by the sublimation or vaporization of volatile substances in the rocks. The pictures confirm, on the other hand, that deformations of Mercury's crust are essentially related to the contraction and the faults and escarpments. There are dozens of zones, usually located within craters and basins, which display signs of crustal expansion. The X-ray spectrometer made some important discoveries about Mercury's composition. Mercury's surface is unlike the soil of the Moon, which is dominated by feldspar-rich rocks. These measurements confirm observations made by telescopes from Earth that suggest sulfides on Mercury's surface. The blocks of material used to create Mercury were less oxidized as a result. This theory could have significant implications for our understanding of Mercury's volcanism. The altimeter of a messenger has revealed that the highest peaks on Mercury are 5 miles high, which is comparable to Everest. After several orbits, the magnetometer on board Mercury determined that Mercury's magnetic pole is located 300 miles north of its center. The magnetic field is generated by the molten metal core located in the center of the planet. This core has a significant north-south asymmetry. The magnetic field is asymmetrical at the south pole due to a large hole. This allows solar wind particles hit the surface. This pulls atoms off the surface of Mercury, feeding the tenuous atmosphere while polishing the soil. The mission was extended and other results were obtained. The neutron spectrometer on the space probe proved that there is water ice on Mercury's surface, despite the high temperatures of up to 752 Fahrenheit. The ice is kept in permanently shaded areas in the polar regions. Cameras show dark materials in these locations, which, according to scientists' hypotheses, are composed of organic molecules, such as comets or asteroids. These objects would have been the source of the water. This discovery challenges the model for the formation of our planet. Mercury's metallic core has contracted due to cooling. Cliffs of solid phase several hundred miles in length and miles high have been formed on the surface of Mercury. The altimeter data collected by Messenger have allowed us to re-evaluate Mercury's diameter reduction. The Messenger took more than 270,000 photos between November 3, 2010 and 16, 2010, while it circled Mercury 4,104. A Messenger's wide-angle camera took 34 photos, allowing us to create a photo montage of the entire solar system. The only planets that aren't included are Uranus and Neptune. they can't be seen at such a distance because they are located between 1.5 billion and 2 billion miles away. The probe, after studying the topography of the northern hemisphere and characterizing the volatile elements in the constantly shaded craters at the poles, crashed onto the surface of Earth on April 15, 2015. It's time to launch a new mission. The Piccolombo is currently on its way toward Mercury. It left on October 19, 2018. The Piccolombo, which left on October 19, 2018, is currently on its way to Mercury. The Piccolombo mission consists of two separate orbiters, the Mercury Planetary Orbiter MPO provided by the European Space Agency ESA, and the Mercury Magnetospheric Orbiter MMO provided by the Japan Aerospace Exploration Agency JAXA. The primary objectives of the Piccolombo mission are to study the origin and evolution of Mercury, its magnetic field, geology, composition, and its tenuous atmosphere. In addition, the mission will investigate the presence of water ice in the planet's polar regions and further analyze the organic-rich material previously discovered by the Messenger mission. The MPO will focus on the geological and compositional studies of the planet's surface, including mapping Mercury's surface at a high resolution, while the MMO will study the magnetosphere and the interaction between the solar wind and the planet's magnetic field. This dual approach will provide a more comprehensive understanding of Mercury's environment and its formation. The Piccolombo mission will also attempt to address the questions raised by the Messenger mission regarding the model of Mercury's formation and the presence of water ice on its surface. By obtaining detailed measurements and observations, scientists hope to gain insights into the early stages of the solar system's formation and the processes that have shaped the innermost planet. Overall, the Piccolombo mission aims to build upon the findings of the Messenger mission, offering a deeper understanding of Mercury's complex geology, magnetosphere, and history. The data collected by the two orbiters will not only help to improve our knowledge of Mercury, but also contribute to our understanding of the formation and evolution of terrestrial planets in general. Venus, jewel of the sky. Astronomers call it the morning star or evening star. The two celestial bodies were considered to be separate at that time. Venus is named after the Roman goddesses of beauty and love. Clouds swirling thick layers. Astronomers call Venus the Earth's sister planet. Both planets have similar sizes, masses, densities, and volumes. Both were created at the same time, and both came from the same nebula. Its destiny, however, decided differently, and it did so over time in a very different way from Earth. It is not surrounded by water and has a dense atmosphere dominated by carbon dioxide. The clouds of the planet are made up of sulfuric acid droplets. At its surface, the atmospheric pressure is 93 times greater than that at sea level. How did it get to that point? Its oceans are slowly evaporating on the second closest planet to our sun. Water vapor, which is now a powerful greenhouse gas that allows the sun's radiation to heat the Earth without letting it escape, has become a powerful greenhouse gas. In a few hundred million of years, global warming intensified and the oceans evaporated completely. The water then concentrates on the upper layers of the air. The ultraviolet rays from the sun then broke down the water molecules. The heavier hydrogen atoms were lost in space, while the oxygen atoms remained on the surface. Venus, arid and without regular volcanism or plate tectonics, was unable to expel its heat for hundreds of millions of years. The pressure increased constantly. As the pressure increased, the planet began to release carbon dioxide through its volcanoes. Carbon dioxide is now the main greenhouse gas. It has replaced water and, because of the numerous volcanoes on Venus, which are much more frequent than those on Earth, it is constantly released. The carbon dioxide in the atmosphere accumulates in a massive amount. It makes up today more than 97% of the atmosphere of Venus. The average temperature on Venus is 860 degrees Fahrenheit, but it can reach 968 degrees Fahrenheit. The composition of Venus' atmosphere also includes sulfuric acid. This gas is very reflective and makes Venus so bright. Sometimes the sulfuric acid is deposited as corrosive rainfall. Venus rotates around the sun once every 225 days on Earth, unlike the other planets in the solar system. Venus rotates in reverse, or backward. The sun is always rising in the west and setting in the east. It takes 8 Earth months to go from sunrise to sunrise. Venus has longer days than the Venetian year. The atmosphere of Venus, which lasts 243 days terrestrial time, is extremely dense and thick. The atmosphere of Venus is 93 times higher in pressure than Earth's air, and it is 50 times denser. On the surface of Venus, winds are slow. They only move a few miles an hour. The atmosphere is dense, which makes the winds particularly powerful. Volcanoes cover the Venetian ground with lava. The heat makes the lava take a long time before it solidifies, but the lava covers the ground in basaltic rock. Venus has more volcanoes per square mile than Earth. To give you a better idea, Venus is home to 167 large volcanic islands with a diameter of over 60 miles, whereas the only volcano of this size on Earth is Hawaii. On Venus, there are nearly 1,000 impact craters evenly spread across its surface. Around 85% of the impact craters on Venus are in perfect shape. A large number of craters and their excellent condition indicate that the Earth underwent a global resurfacing between 300 to 600 million years ago. Venus' crust moves continuously, but it would not be able to maintain this process without plate tectonics dissipating the heat from its mantle. Venus instead undergoes a cyclic, if not a chaotic process, where the temperature of its mantle increases until it reaches a critical point that weakens its crust. Subduction takes place on a massive scale over a 100 million year period, recycling the crust of the planet. The extreme conditions on Venus made exploration very difficult. Probes that were sent to Venus only lasted a short time before they stopped functioning. Mariner 10 took the first images in 1974 as it passed Venus on its journey to Mercury. The ultraviolet photos of the clouds revealed the high winds in the Venetian air. The first black and white images of Venus' surface were transmitted in 1975 by the Soviet landers Venera 9 and Venera 10. The first color images were taken in 1982 by the Soviet landers Pioneer Venus 14 and 13. The images enabled us to see that the surface was covered in sediments and relatively angular rock. Sulfur in the air may indicate recent eruptions. In an attempt to measure wind speeds, the microphones on the probe recorded atmospheric wind noise. It was the first time a sound had been recorded on another planet. Magellan mapped the surface of Venus in great detail a few years later. According to information collected by the American probe Magellan in 1990, the internal structure on Venus was indeed comparable to that of the Earth. It would consist of a sea-like solid core and a liquid core. This core would then be surrounded by a solid, viscous mantle as well as a solid crust. This model is purely hypothetical. The question remains as to the composition of Venus' core because it remains open. The Earth's external core is composed of a hot, electrically conducting fluid in which convection occurs. The conductive layer combined with rotational motion produces a dynamo effect to maintain an electrical current system, also known as a magnet field. Two different explanations could be given for the absence of an inner magnetic field of Venus. The rotation of Venus is either too slow to sustain an electric current, or the core of Venus is solid. In the decades that followed, several other missions explored the space around Venus, but Akatsuki is currently the only probe present. The planet of thousands of colors, and the birthplace of mankind. The oasis of life has still much to tell us about our origins and mystery. What to do first? While there's much to say, sometimes pictures speak louder than lengthy speeches. Following the Mariner 10 mission, several other missions have attempted to explore and understand the mysterious environment of Venus. In 1975, the Soviet Venera 9 and 10 landers successfully transmitted images of the rocky surface of Venus, despite the harsh conditions. These landers were able to function for a short period of time before succumbing to the planet's extreme temperature and pressure. In the 1980s, the Soviet Union's Venera 13 and 14 landers provided additional images and valuable data about the surface composition, which helped scientists to better understand the geology of Venus. These missions were followed by the Vega 1 and Vega 2 probes in 1985, which released balloons into the Venusian atmosphere to study its composition, temperature, and wind patterns. NASA's Magellan mission, launched in 1989, used synthetic aperture radar to map nearly the entire surface of Venus in high resolution, revealing a complex landscape characterized by volcanic activity, mountains, and large rift valleys. Magellan's data indicated that Venus' surface is relatively young, supporting the theory of the cyclic process of crustal recycling. More recently, the European Space Agency's Venus Express, which orbited the planet from 2006 to 2014, provided detailed information about the atmosphere, surface, and climate of Venus. The mission discovered that the planet's atmosphere has several layers with varying wind patterns, and that lightning is a common phenomenon on Venus. Currently, the Japanese spacecraft Akatsuki, which entered orbit around Venus in 2015, is studying the planet's atmosphere and weather patterns. Its primary goals are to understand the mechanisms behind Venus' thick cloud cover and the intense winds that whip around the planet. Future missions to Venus, such as NASA's Da Vinci Plus and Veritas, as well as ESA's Envision, are set to launch in the 2030s. These missions will further study the geology, atmosphere, and surface conditions, aiming to unlock the secrets of Venus' evolution and better understand the processes that led to its current state. These missions also hope to provide insights into the potential habitability of other Earth-like planets in the universe. As we prepare for the upcoming missions to Venus, researchers and engineers are working on developing new technologies and materials capable of withstanding the planet's hostile environment. Improved heat-resistant electronics, pressure-resistant structures, and advanced communication systems will be essential for the success of these missions. One of the main goals of Da Vinci Plus Deep Atmosphere Venus investigation of noble gases, chemistry, and Imaging Plus is to send a descent probe through Venus' atmosphere to obtain precise measurements of the chemical composition and study the atmospheric structure. By better understanding the origin and evolution of Venus' atmosphere, scientists hope to gain insights into the potential habitability of the planet in the past and learn about the processes that led to its current inhospitable state. Investigating Venus can also reveal insights into the potential consequences of climate change on Earth, as Venus is often considered a cautionary example of a runaway greenhouse effect. By studying the atmospheric dynamics and chemistry of Venus, scientists can better understand how the balance of greenhouse gases affects the planet's climate and habitability. Moreover, studying the similarities and differences between Venus and Earth could help us refine our models of planetary atmospheres, leading to a deeper understanding of climate change on our own planet. The exploration of Venus also presents an opportunity for international collaboration in space exploration, as missions to the planet often involve multiple space agencies working together. This cooperation can lead to the sharing of resources, knowledge, and technological advancements, furthering our collective understanding of the universe. Finally, the challenges posed by Venus' extreme environment continue to drive innovation in spacecraft design and engineering, which can have valuable applications not only in space exploration, but also in various industries here on Earth. Mars, which is the fourth planet from the Sun and about half the size of Earth, has a small size. It was once covered in salt, warm seas, with freshwater lakes. There would also have been clouds, snow on its mountains, and even a water cycle. The American probe Mars Reconnaissance Orbiter detected water and brine in 2015. This liquid is similar to salt water from our oceans. It also contains saturated salts. Salts are extremely absorbent and lower the freezing temperature of the water. This allows it to flow in liquid form at temperatures as low as 32 degrees Fahrenheit. The surface of the red planet fluctuates between 68 and plus 225 degrees Fahrenheit. NASA announced in early June 2018 that the rover Curiosity had identified a methane cycle on Mars and organic molecules. The American rover in Mars 2012 was able to use the same instrument to identify carbon and hydrogen chains within rocks older than 3 billion years. The liquid water on Mars would have been flowing at the time. Two ingredients for the appearance and development of life on Mars were likely gathered simultaneously. Mars is a terrestrial, or rocky planet. It's 10 times smaller than the Earth from the perspective of the blue planet. The dust is rich in the iron oxide that covers the surface, giving it a reddish hue. Iron oxide, once hydrated, turns rusty. This is the reason for the color of the planet next door. It is because of this that it has been linked to war from ancient times. The name refers to the god of war in Roman mythology. The poles are always covered in whitish caps that vary according to the season. The ice at the North Pole is sublimated by the sun during the springtime of northern latitudes. It goes from a solid to a gaseous form. Sublimation creates wind masses, which in turn raise significant amounts of dust, triggering dust storms that could affect the entire planet. The planet Mars, on the other hand, is marked by an obvious opposition between its northern hemisphere, consisting of vast plains, and the southern hemisphere made up of plateaus with many impact craters. The northern hemisphere lies between 0.6 and 2 miles lower than its southern counterpart. The thickness of the crust is 20 miles in the northern hemisphere and 35 miles on the southern plateaus. It is thought that this dichotomy appeared around 4 billion years ago. Two theories are proposed to explain this phenomenon. The first theory is related to internal dynamics at the level mantle and of plate tectonics, while the second suggests that one or more large impacts would have caused the melting of the terrain in the northern hemisphere. The northern hemisphere terrains are also younger than the southern hemisphere and are marked by a former presence of acidic and abundant liquid water near the geological boundary. The dichotomy manifests itself in the high concentration of volcanic activity in these areas. Olympus Mons, the largest volcanic structure in the solar system, is situated on the bulge. It has an altitude greater than 21,000 yards. Mars, unlike Earth, does not have plate tectonics. This explains why its volcanoes are so massive compared to ours. Mars' crust moves in relation to hot spots within the mantle. These hot spots eject lava on the surface and form a series of smaller volcanoes. The lava, however, accumulates in one place, resulting in gigantic volcanoes. Mars' internal geological activity has largely ceased. There are still a few landslides at the poles and a few earthquakes. The southern hemisphere is covered with impact craters. Gare Planitia and Hellas Planitia stand out as the most notable. The largest impact structure that can be observed on Earth is the latter, with a radius of 1,370 miles and a depth of 9,500 meters. Martian craters are subject to atmospheric erosion, altering the shape of their interiors and covering them with dust. They are still clearly visible. The surface of the red planet also features the largest canyons in the solar system. The Valles Marineris Canyon span over 1,800 miles and reach depths up to 8,000 meters. The dry riverbeds that are found in the valleys of Mars remind us of a time when water was flowing freely on Mars. The surface gravity of Mars is 38% less than that on Earth. Microgravity can cause health issues such as mineralization and muscle loss. This does not deter plans to colonize Mars. The seismometer of the InSight mission, which reached its destination on the 26th of November 2018, sheds some light on certain points. Theoretical models predict that Martian earthquakes will be weaker, but they are more frequent. In just 13 months, nearly 460 events were recorded, most of which were microearthquakes. Scientists have been able to refine their knowledge of Mars' internal structure by analyzing seismic waves of a few earthquakes that were observed most intensely over a period of 2 years. Scientists were able to discern 3 subsurface layers using seismic recordings. The regolith is a surface stratum that has been formed over billions of years by material crushed by impacts. A weathered layer, about 10 miles thick, is found below. This crustal layer is similar in its attenuation and scattering of waves to that of the terrestrial crystalline mass. The magnetometer detected an incredibly high magnetic field. It was 10 times greater than what had been expected. The rocks around the landing site were too young to be magnetized by Mars' ancient global magnetic field, so the field measured must have come from deeper rock. InSight detected magnetic pulses that were still unidentified in the middle night. The Martian atmospheric composition is 96% carbon dioxide with 2% argon and 1.9% nitrogen. Images from the surface show the sky as orange. This is likely due to fine dust particles suspended in the air, similar to the ones found on Earth. Mars' atmosphere is extremely thin. It has a pressure less than 1% that of Earth. Where does Perseverance fit into all of this? Perseverance rover's first results have been delivered 8 months after it landed on the red planet. Scientists expected that the Jezero crater, where the robot landed, was indeed a dry lake. It has been around 3.6 billion years since the last time it rained. According to a first study based on data collected by France's Perseverance SuperCam camera, the lake had a 17-mile diameter and was several yards in depth. The red planet does not have rings, but rather two small satellites called Phobos and Deimos. Phobos orbits Mars at a distance of about 5,500 miles. The planet's gravitational pull is causing it to slowly fall towards Mars at a rate of 18 centimeters per year. In 11 million years, Phobos will have gotten so close to Mars' surface that its gravitational pull would cause it to dissolve at an altitude of about 2,500 miles. Deimos is smaller but more distant. It orbits at an altitude of around 14,000 miles. It is also irregularly shaped and covered with craters. According to the most recent scientific publications, the two moons named after the twins Mars and Venus of Roman mythology would be the remains of an impact between a red planet and an asteroid. This collision would have created a ring of debris around which 12 satellites could have accumulated. Only two satellites, Phobos and Deimos at the farthest distance, would have survived. The main belt of asteroids in the solar system is located between the orbits of Mars and Jupiter. It is estimated that over 150 million objects are located in this area. Ceres is the largest dwarf planet. Dawn is NASA's space probe, whose mission it is to study Vesta, the main body in the belt of asteroids and Ceres. Dawn was launched in 2007 and began orbiting Vesta in 2011 and Ceres in 2018, and finished its observations in 2018. What did the probe actually see on Ceres, though? Dawn's images show a surface homogeneity with many craters. These bright spots are carbonates and salt deposits. Ceres' surface was complex due to the combination of old and new terrains. Many clues such as the direct measurement of hydrogen and trade flows show that the ice is plentiful at high latitudes. The presence of large craters, some up to 150 miles across, suggests that the crust is more solid than ice. The study of surface formations indicates that as you approach the dwarf planet's center, the density increases. Ceres has a highly differentiated core made mainly from rocks and a mantle that is rich in water. Ceres is distinguished from other asteroids by this characteristic. Ceres' surface has been found to contain ammonia. This discovery confirms that Ceres' current configuration is the result of a series of significant changes. Dawn's infrared spectrometer has determined the source of the bright spots in the Equator crater region. Carbonate is a major component of these formations. This mineral is more abundant at this site than in any similar formations found on Earth. A locator, on a geological level, is a crater that has a relatively recent age estimated at 80 million years. Carbonates are a sign of hydrothermal phenomena on Earth, and hot water is implied by their presence. Scientists have estimated that Ceres' interior is hotter than they thought. Scientists now know that liquid water existed beneath the surface of the asteroid in recent geologic history. These visible salts are the remnants of an ancient ocean or pockets that have reached the surface. Dawn's infrared spectrometer has also detected ammonia salts within the Oxo crater. Ceres have previously been found to have clays containing ammonia. This discovery, along with the carbonates, supports the hypothesis that Ceres was formed in the outer solar system towards Neptune's orbit, and then its orbit moved into the inner solar system. The study of Ceres' surface seems to contradict that hypothesis. In fact, even craters that are deeper than a mile and were formed by impact billions of years ago do not show any signs of deformation. According to the study, if the surface were only composed of ice, then this type of relief would have faded with the heating and cooling periods. The surface's external layer would contain no more than 30 to 40 ice. The remainder is made up of minerals and rocks. The presence of minerals does not explain the rocky surface of bodies that are formed close to the sun. Dawn's instruments captured 31,000 images of Vesta's surface over the course of its orbit. These data enabled us to establish that Vesta was very different from other asteroids. Its geology has a complex structure. It has a core made of nickel and steel with a diameter between 130 to 140 miles. Vesta, with its 330-mile diameter and mantle above the core, has many characteristics of a planet. Vesta's evidence, which shows that there was a powerful magnetic field 3.6 billion years ago, supports this affiliation. This liquid metallic core was capable of generating at that time. Even today, traces of this magnetic field may still be visible. Both hemispheres have a different appearance. Vesta's northern hemisphere is riddled by impact craters that trace its turbulent 4.5 billion year stay in the belt of the asteroid. The southern hemisphere of Vesta was completely reshaped after a massive impact that took place at least 2 billion years ago. A second collision, even more powerful, occurred around 1 billion ago. The basins Veninia and Rhea Silvia were formed by these two events. Veninia is nearly 250 miles across, while Rhea Silvia is 310 miles. The peak of Everest is located in the middle of the large basin. It was so powerful that it nearly shattered Vesta and left a vast network of depressions hundreds of miles in length and 9 miles wide near the equator. The impacts caused a large amount of rock to be thrown into space. Some of these rocks have fallen on Earth. Vesta is a bright asteroid and the only one in the belt that can be seen by an observer on Earth. According to Dawn's observations, this is because of the presence of bright areas ranging in size from 100 yards up to 10 miles that are twice as bright as the rest of Vesta's surface. These are mostly found near or in the impact craters. The original material of these terrains, which dates back to 4 billion years ago, was exposed when asteroids crashed into Vesta's floor. Dark areas can be seen next to these bright surfaces. These dark areas could be remnants from asteroids that hit the surface at low speeds or parts of the salted bowl crust that have melted due to more violent impacts. Instruments on the space probe allowed us to identify the composition of rocks at the surface. They are mainly composed of minerals rich in magnesium and iron. We were able to determine the composition of surface strata by identifying landslides, impact craters, and very fine gravity measurements. The map of surface temperatures shows that the temperature ranges from -10 degrees Fahrenheit to -148 in areas with shade. According to observations, the asteroid, which is half ice, is not visible at the surface. The asteroid's axis is inclined strongly at 27 degrees. This is a higher angle than the Earth's 24 degrees. All points of the surface, even the size and shape of the crater, are exposed to sunlight at some point during the year. Jupiter's size and the constant storms that rage across its surface make it a spectacular planet. Since antiquity, astronomers have observed the gas giant. The American mission of Juno is beginning to unravel many mysteries about the nature of Jupiter and its moons. Jupiter, a gas giant planet that will soon be completed by the European JUICE mission, is composed mostly of gas, 95% including helium, hydrogen, and argon. It is still larger than the combined mass of all the planets in the solar system. Its volume is equal to 1321 times the Earth's. The Roman god Jupiter, or Zeus, according to Greek mythology, is the inspiration for its name. Jupiter is fifth from the Sun, and although it has been known for centuries, its composition and structure is still a mystery. According to the current state of knowledge, a star's atmosphere is made up of a thin, gaseous layer that is about 600 miles thick. It is rich in molecular helium at 13% and 86% molecular hydrogen. Ammonia is responsible for the dense clouds that have brown, red, and white colors. As temperature and pressure increase with depth, the hydrogen condenses gradually into a thicker fog. Eventually, it transforms into a liquid sea of molecular hydrogen and helium. The sea lies between the lower gaseous part of the atmosphere and a depth of about 6,200 miles. The temperature between 6,200 miles to 37,000 miles is over 36,000 degrees Fahrenheit, and the pressure exceeds 40 million times the Earth's atmosphere. This layer contains metallic hydrogen in a liquid form, similar to that of mercury. This intense pressure causes the hydrogen molecules to break down, losing one or more of their electrons. They then transform into chemical species known as ions. This layer is thought to be responsible for Jupiter's powerful magnetic field. Research is also pointing to the presence of a solid, rock or ice-based core in the planet's center, with a mass 3 times greater than that of Earth. Jupiter is a turbulent and complex world. Data collected by Juno's instruments has challenged many scientific beliefs about processes. Juno has discovered a new radiation band at the equator just above the atmosphere. It is indicated by a bluish spot. The spacecraft passes also through a radiation belt previously located at high temperatures. A new radiation belt has also been discovered near the equator and directly above the atmosphere. Juno's images show that storms as large as Earth are located very close together in the polar regions. Scientists are fascinated by their dynamics and formation. Are these storms a permanent phenomenon? Do they change over time in their appearance? Has the storm moved? The data collected on polar auroras indicates that processes are different than those on Earth. The electrons at the poles can reach energies up to 400 electron volts. This is 10 to 30 times more than what we observe on Earth. Scientists were surprised to learn that despite the enormous electrical potential of the auroras, they are not permanent. The most intense auroras also aren't related to the characteristic. Juno's camera captured detailed images of Jupiter, including its iconic feature, the Great Red Spot. According to radiometer measurements, the Great Red Spot is at least 150 miles in depth and hotter at its bottom than at its surface. It is actually a huge storm similar to a tropical hurricane. Juno flew very close to Jupiter's eye at an altitude of around 5,500 miles. The cyclone is estimated to be 10,000 miles in diameter, which is about 1.3 times Earth's diameter. Scientists still do not have an accurate estimate of the storm's depth. The eye of Jupiter, which is between 50 and 100 times deeper than Earth's oceans, is hotter near its base than the top. This temperature difference is what causes the winds to reach 400 miles per hour. The radiometer on board indicates that the deep layers of Jupiter's atmosphere are moving. These layers are located between 25 and 50 miles beneath the cloud tops. Contrary to what scientists believe, instant energy is not present at this depth. A radiometer cannot measure more than a few hundred miles due to gravity field measurements. The digital science team found that the horizontal stripes on the surface are actually winds at 1,800 miles deep. This is a limit much lower than expected. Contrary to what was previously believed, the atmosphere does not consist of layers that are differentiated in rotation speed below it. Lower layers, liquid or solid, have the same rotational motion. They behave as one entity. According to the results of measuring the gravity field, it's possible that a rock and metal core of Earth size, or even a super-Earth existing during the formation of Jupiter, has dissolved and merged with the liquid metallic hydrogen mantle. Jupiter's magnetic field intensity, measured precisely, is higher than expected at 7.7 Gauss. The instrument was able to show that the field was irregular. This indicates that the dynamo which generates the magnetic field is closer to Jupiter's surface than expected and will be located above its metallic hydrogen layer. The launch is scheduled for June 2022. In 2029, the European Space Agency mission JUICE is scheduled to join Juno Jupiter. It will be observed Jupiter and its three largest satellites, Europa, Ganymede, and Callisto. It is believed that each of these satellites contains an ocean beneath the solid crust within the Jupiter system. Jupiter has 67 moons named after it, of different sizes, shapes, and compositions. These moons are also referred to as the Jovian moons. The four largest moons, Io, Europa, Ganymede, and Callisto, are collectively known as the Galilean moons. Ganymede is the largest moon of the four, bigger than Mercury. Three of these moons, Europa, Ganymede, and Callisto, are also believed to or have known internal oceans near or at their coronal boundaries. Warm water oceans are considered a sign of possible life on these moons. Galileo was launched on October 18, 1989. 6 years later, it reached Jupiter and its satellites to study them until 2003. One of the most extraordinary planetary exploration missions was punctuated by setbacks and milestones. Galileo was able to collect a great deal of scientific data despite its inability to deploy the large antenna. This severely limited the amount of transmitting data. Io is 1,100 miles in radius and 260,000 miles away from Jupiter. Io has been completely engulfed by Jupiter's magnetic field. The orbital period is the shortest of all the Galilean moons, at 42.5 hours. Io is the densest moon in the solar system and significantly heavier than any other Galilean satellite. Io is composed of silicate rocks, iron, and water. Its bulk composition is more similar to that of terrestrial planets than the other outer solar system satellites, which are mainly made up of a mix of water, silicates, and ice. Io, unlike its Jovian cousins, have no ocean of warm water beneath its surface. According to magnetic measurements and heat flux observations, a magma ocean is thought to exist about 30 miles beneath the surface. As can be seen by the heat flow, this heat is responsible for the volcanic activity on Eos. The Galileo probe flew by Jupiter's Io satellite 7 times. However, the first and final flyboys produced very little scientific data. Observations have revealed that there are more than 100 volcanoes active on the surface of the moon. Loki is the most powerful in the solar system. The lava produced by these volcanoes is enormous, and according to experts, Io is a perfect example of hell. For such violent phenomena, we must go back at least 2 billion years into the Earth's history. The camera on the space probe was able to capture close-ups showing an eruption of lava rising more than a mile above the surface of the moon. Io's surface is covered in smooth plains with pits and mountains of all sizes and shapes. Volcanic lava flows are also visible. The colorful appearance of Io is due to volcanic activity, which has coated the surface in sulfuric and silica compounds. This has led to a renewal of the surface. Io is the only known body in the solar system that has the least amount of water. This is likely due to Jupiter being sufficiently hot to remove the volatile matter such as water from its surface at the start of the evolution. Geological phenomena are caused primarily by the tidal force generated by Jupiter. These forces fluctuate depending on the position of Io within its orbit because it is not circular. These forces deform our planet like a rubber ball. Internal friction between the rocks produces enormous amounts of heat. This heat flow is twice as significant as the heat that was generated at the beginning of Earth's volcanoes. The space probe discovered mountains that reached 8 miles in height and didn't appear to be volcanic. These peaks appear to be slowly disappearing due to massive landslides that are caused by the mass. A hole discovered by Galileo at the level Io in the magnetic field of Jupiter, combined with measurements of the gravitational field of the moon, allows us to conclude that the metal core is made of iron and iron sulfide with a diameter of 500 miles. This is about 50% of the total diameter. The instruments of the probe noted that the ionosphere was present at 500 miles altitude during its first flight over Io after arriving in the Jovian system. According to the data collected by previous space probes, it was expected that the ionosphere would culminate between 25 and 50 miles. These differences show the diversity of this area of space. Europa is calm, icy, and watery compared to Io, which can be described as a hellish, lava-spewing place. Europa's average radius is about 1,000 miles, and its mass is 8 times 10 in the 22nd lb. It's slightly smaller than Earth's moon. Its orbit, which is almost circular, lies an average distance from Jupiter of 416,000 miles. It takes the moon 3¼ Earth days to complete one orbit around Jupiter. Galileo made 9 close flybys to Jupiter's satellite Europa. The spacecraft was in survival mode during 2 of the flybys, which resulted in little data. The last flyby took place in the context of a budget that was reduced, which only allowed for limited observations. According to observations of Jupiter's other moons, Europa does not have many craters. This indicates that geological processes may have caused them to disappear. Every million years, an average impact produces a crater with a diameter of about 10 miles. Observations made by the probe have revealed only 10 craters this large. According to most scientists, the surface of Europa has existed for less than 10 billion years, making it younger than any other planet except Earth. Images taken by Galileo support this theory. The images show blocks of crust that look like icebergs on an invisible sea. The blocks appear to be tilted or rotated as if they were released from pressure. They rotate. Surface features include long ridges, fractures, and bands of dark-colored rock and ice. This process is likely the result of the tidal force generated by Jupiter and its moons. These forces lift the surface tens or even hundreds of feet each day. They also cause volcanic eruptions and geysers to disperse the material from deep layers. Europa is denser compared to the other Galilean moons except Io. This indicates that it has a different interior, a rocky interior made of silicate rocks, and possibly an iron core. A layer of water ice is estimated to have a thickness of 60 miles above this rocky interior. Numerous data point to the existence of an ocean under the ice covering Europa. Only if water or hot ice is used to heat the ice surface layer from below can we explain the youthfulness of the ice surface and the presence of icebergs in certain regions. In the youngest regions, an infrared device detected concentrations of sulfates and carbonates. These deposits can be explained by a salty sea located beneath the ice crust. If the ocean waters are carbonaceous, then enough pressure can be created to expel debris from the surface of Europa. A laboratory experiment that recreated the conditions on Europa enabled us to confirm that the electromagnetic spectrum for salts was in accordance with this theory. The magnetic field characteristics of Europa are the strongest argument for the existence of a subterranean ocean. The magnetometer on the space probe detected a magnetic field local to it. This field appears to be caused by Jupiter, and not by the moon. This field is thought to be created by the electric currents that circulate in a salty, and therefore conductive, underground ocean. Gravity field measurements indicate the presence of layers of liquid water and ice. The tidal force exerted by the moon would generate enough thermal energy to cause liquid water to exist in such a frigid region. Many scientists have speculated about the existence of life on Europa based on the theory of a subterranean sea. Galileo's observations of Jupiter's magnetic fields showed that they exerted a significant influence on the ions in Europa's oceans and could potentially cause oceanic currents. This current would move at a speed of several inches per second in the opposite direction to Europa's rotation. This could explain the faults on the surface of the moon. It is possible that this ocean contains organic life due to the combination of all these factors. Ganymede. Ganymede, the third most distant moon of Jupiter, orbits at an average distance of 600,000 miles. One revolution takes 7 days, 3 hours. Ganymede, like most other moons known to man, is tidally locked with one side facing the planet at all times. It has a radius of approximately 634 miles. This is the equivalent of about 0.4. Ganymede, the largest of the moons in the solar system, is even bigger than Mercury. It is half the mass of Mercury, but with a 3 times 10 to the 23rd pound mass. It is because of its composition, which consists mainly of silicate rock and water ice. Galileo collected data by flying 6 times between 160 and 20 miles above Jupiter's satellite Ganymede at low altitudes. The magnetic fields around Jupiter indicate that Ganymede is Jupiter's largest moon. It has an internal dynamo, similar to the one on Earth, and a metallic core. The core, which could be pure iron or iron sulfide depending on its composition, may be 250 to 800 miles below the surface. Its mass can range from 1.4% to 1/3 of the moon. It is the first time a magnetic field on a natural satellite has been detected. Ganymede's surface is divided into 2 distinct types of terrain. Around 40% of the surface has dark craters that date back to when the moon was formed. The rest of the surface is composed of lighter colored and softer terrains called sucrose. These would have been formed more recently as a result of underground water. This type of terrain is crisscrossed by ridges that can reach up to 700 miles long. The younger terrains may have formed when the orbital shape of the moon was elliptical. This would have led to changes in the tidal force, which could have fractured the ice sheet or caused groundwater eruptions. These craters, with a size between 30 and 25 miles, are flat. This could be because the ice from which they were carved is softer than the rock that formed the lunar craters, for instance. Ganymede also has a magnetic-induced field by Jupiter. According to the scientist in charge of this mission, the magnetic field would be generated by materials that are more conductive than the ice. This magnetic field could be caused by a salty sea with a depth equivalent to terrestrial oceans located 100 miles below the surface ice. Callisto, the most distant Galilean moon, orbiting Jupiter at an average distance of 1 million miles with an average radius 1,500 miles or 0.3 times larger than Earth and a mass 1% that of Earth, is the most remote of all the Galilean moons. Callisto, the second largest of Jupiter's moons, is 0.3 times larger than Earth. Its mass is 1% that of Earth. Callisto is the second largest moon of Jupiter. Galileo flew by Jupiter's satellite Callisto 9 times. Data collected shows that the moon's composition is a mix of iron and iron sulfate, with rocks making up 60% of its mass and ice accounting for 40%. It does not have an identifiable central core, unlike Ganymede. Callisto, being located at a greater distance than the other Galilean moons from Jupiter, was not as exposed to the intense heat caused by the tidal force of the giant planet. The differentiation process, which is supposed to lead to a layer structure with greater density and depth, as well as a metallic core, remains unfinished. The possibility of an ocean beneath the surface of Callisto, like Europa and Ganymede, has led scientists to speculate on the possibility of life. It is more likely to happen if the inner sea is made up of salt water. For example, halophiles thrive in high concentrations. Europa and Ganymede are more likely to have the conditions for life, including the existence of enough heat from tidal bends. Callisto is different because the interior ocean does not come into contact with the rocks. Callisto lacks energy, but it has the probiotic chemistry needed to support life. Jupiter's 4 satellites. A magnetic field circulates between Jupiter's small satellites and the 4 Galilean moons. When the Galilee mission was extended, it became possible to observe this large moon at a distance of about 170 miles. The spacecraft took pictures that were relatively detailed. Galileo captured images of the collision between Comet Shoemaker-Levy 9 and Jupiter. Jupiter and its satellites remain a top priority. The New Horizons spacecraft flew above Jupiter and its satellites on February 27th as it was heading to Pluto. The cameras were more powerful than Galileo's and allowed for better images of the planet. In 2016, the Juno spacecraft was launched in 2011 and entered the polar orbit around Jupiter to study Jupiter's atmosphere. In 2022, the European Space Agency will launch a space probe to study Ganymede. It will then conduct further research after it has placed itself in orbit on the moon by 2030. Cassini's long stay near Saturn allowed us to study Saturn's unique atmosphere at its north pole. The Voyager 2 space probe discovered the cloud system in 1981. It has a hexagonal shape that remains stable over time. Each side measures 8,500 miles and completes a full orbit in 10 hours, 39 minutes. The Eye of the Hurricane is located in the middle of the formation. It has a diameter of 1,200 miles and drags clouds at speeds of over 310 miles per hour. Saturn has vortices inside the hexagonal shape. It is not known what mechanism caused the formation. Saturn's year is a little more than 29 Earth years long. A tilted axis of the planet is similar to Earth. Multiple times, a seasonal storm associated with surface heating, which occurs every 29 years, has been observed. Cassini's arrival, also known as the Great White Spot, due to its apparent characteristics, marked the beginning of a number of white spots which gradually expanded in longitude and encircled the planet. Although the cause of this has not been explained, the storm always appears in the northern hemisphere. The storm was studied in depth when it appeared in December 2010, 10 years before expected. The space probe found that the storm can bring up water vapor and other materials as deep as 100 miles. Instruments on the probe saw lightning for the very first time in this storm. It occurred on both the illuminated side and the dark side of the planet. It is important to determine the sidereal rotation of a planet in order to study associated physical phenomena and establish a system of longitude. For terrestrial planets, the rotation period can be determined by observing the surface. Gas giant planets have no solid ground and their core is buried deep beneath the atmosphere. Only the magnetic field can be used to determine the rotation period of these planets. We studied the modulations caused by the rotational motion of the magnetic field to determine the sidereal rotation period. Data from Voyager helped determine the first rotation period of Saturn. Saturn's sidereal period is 10 hours, 39 minutes. Scientists using data from the Ulysses space probe in 2000 noticed that Saturn's modulation period had changed Voyager measurements. The new measurements showed a period that was 1% longer than the one measured by Voyager. Cassini's radio measurements confirmed this variation. Observations between 2004 and 2006 around Saturn indicated that the radio phase slowly changed on an annual scale by a few percentages since the sidereal rotation of Saturn's ring cannot change. It is important to review the interpretation of modulations in radio emissions. Radio emissions are observed mainly on the magnetosphere of Saturn, and they are highly correlated with solar wind pressure. There are currently different interpretations. First, there is the seasonal effect. The number of electrons that are free on the magnetic field line changes when the sun is at the height on the plane. The second interpretation could be an effect of solar activity. Solar activity has a strong effect on the properties of both the interplanetary medium and the solar winds. Saturn's radio auroral emissions have been found to be strongly correlated with solar wind parameter fluctuations. Last interpretation: Saturn's core is a convection-like system, similar to what happens in the Sun. However, this hypothesis seems unlikely. This problem is especially complex because if Saturn is indeed rotating 1% slower than Voyager's measurements, then the entire atmosphere of Saturn would be rotating faster than its core. It is hard to explain. Two scenarios regarding the origins of Saturn's rings were proposed before the end of the Cassini missions. According to the first scenario, the rings are the result of an event cataclysmic, such as a destruction of a lunar body or a comet that disintegrated due to gravitational force within the Roche boundary. The rings are relatively young. In the second scenario, the rings are remnants from the formation of the giant planet and would therefore be approximately 4.5 billion years old. Cassini made close maneuvers with the rings during its final orbits in late 2017. These orbits took place between Saturn's rings and the upper layers of Saturn's atmosphere. Cassini made gravitational measurements by observing how the rings affected its trajectory. This allowed it to determine the amount of material accumulated. The rings are composed of 15.4 times 10 to 15 tons of material. This is 20 times less than previous estimates. To put things in perspective, the Moon is approximately 7.6 times 10 to 19 tons. Cassini's more detailed data allowed it to establish that the rings formed between 10 to 100 million ago. They are expected to disappear completely within the next 100 million years. Originally, they must have been larger and more brilliant. Measurements made cannot determine with precision the event that created the rings. However, traces may still be found in the layers of Saturn's satellites. Cassini was able to provide some information about Saturn's magnetosphere. The mission had discovered that unlike other celestial objects with magnetic fields, Saturn's magnetic field coincides with its rotational axis. Cassini discovered that the magnetic field of the Earth undergoes large fluctuations. These occur with a frequency of 10 hours, 47 minutes. Scientists on the probe found that the material in the magnetosphere is a result of geysers at the South Pole, located on the Moon Enceladus. These materials are primarily composed of ions, molecules, and water components that were ejected from the geysers. Scientists had assumed that Titan's atmosphere should have been able to release significant amounts of nitrogen. However, this was not the case. The final phase of the mission involved close passes of Saturn and approaching the interior rings. This was followed by an entry into Saturn's atmosphere on September 15, 2017, to destroy the spacecraft. The mission ended on September 15, 2017, after 22 orbits. The spacecraft is believed to have burned up 45 seconds after its last transmission. Saturn, the distant gas giant, has a beautiful system of rings and satellites. Saturn is second only to Jupiter in the number of confirmed satellites. There are 62 moons. The two largest groups of moons are the inner large moons orbiting Saturn and its fragile ring, and the other large moons beyond the ring. The moons are arranged in order of distance from Saturn. They include Mimas the closest, Enceladus closest, Tethys closest, Dione farthest, Rhea, Titan, and Iapetus. Mimas is 250 miles in diameter and has a mass of 10-20 pounds. Mimas is one of the smaller and less massive moons. It is ovoid in shape, orbits Saturn about 115,000 miles away, and has an orbital period 0.9 days. Its low mass density, which is estimated to be only slightly higher than water, suggests that it's mainly made up of water ice with a very small amount of rocks. Enceladus has a diameter 300 miles, and its mass is 2x 1,020 pounds. It also has a spherical form. It takes 1.4 hours to complete one orbit around Saturn, which is at a distance about 238,000 miles. It is not only one of the smaller spherical moons, but also the only one that is geologically active. The tiger stripes are a good example of this. It has been the subject of several observations since 2005. Titan is the second most fascinating object in Saturn's system. Saturn's magnetic fields near the moon are distorted due to the atmosphere. Flyby at close range revealed that geysers are emitted from the South Pole area with a speed of up to 400 yards per second. water ice mixed with simple chemical compounds. The plume's composition also suggests that the ocean beneath the surface is salinous and contains volatile and organic molecules. The South Pole surface was photographed from a short distance. It showed a young surface with ice blocks the size of houses, fractures that suggested tectonic movement, and a cloud of water vapor. Geysers are erupting from deep crevices known as tiger stripes. Saturn's tidal forces could be responsible for the movement of the South Pole of Enceladus. This force is not only affecting the ice surface layer, but also the volatile substances that are present in the presence of the silica. The presence of an ocean of liquid seawater, organic molecules, and volatile substances in the interior of Enceladus indicates hydrothermal activity. The presence of this energy source in combination with organic molecules and nutrients, as well as probiotic conditions, could indicate that Enceladus is home to extraterrestrials. It is 620 miles in diameter. It is the second largest inner moon of Saturn. Its surface is dominated by a heavily cratered terrain with a density of about 0.9 grams cubic inch. It would consist almost exclusively of water ice. It is not known if it has a rocky mantle and a thin ice core. Dione is 700 miles in diameter and has a mass 22 times 10 to the 28th. Dione is Saturn's fourth largest moon. Dione is a heavily cratered, ancient terrain with craters up to 150 miles wide. The moon is about 230 miles away from Saturn. It takes the moon 2.7 days to make one full rotation. Dione is mainly composed of water ice with a remnant of silicate rocks. Dione also has a very thin atmosphere of oxygen ions, which was first detected by Ulysses Cassini in 2010. The source of the atmosphere is unknown, but it is believed to be the result of radiolysis. This is when charged particles from Saturn's radiation belt interact on the surface with the water ice to produce hydrogen and oxygen. Rhea is 1,000 miles across and has a mass 40 times 10 to the 28th. Rhea is the second largest moon of Saturn, with an orbital diameter of approximately 327,000 miles. It's the fifth farthest moon, and it takes 4.5 days to complete its orbit. Rhea, like the other Cronian satellites, has a heavily cratered surface. Rhea's composition is roughly 75% water ice and 25% silicate. Rhea's low density makes it the 10th most massive moon when measured from its interior. Rhea's interior was thought to be divided into a rocky mantle and an icy core, but recent measurements indicate that Rhea has a homogeneous or only partially differentiated interior. Models of Rhea's interior suggest that, like Jupiter's moon Callisto, there could be an ocean of liquid water similar to Titan. If it did exist, this liquid water ocean would be likely located between Rhea's core and mantle. The ocean would be fed from the heating that is caused by radioactive elements decaying in its core. Titan is the largest Cronian moon. Titan, which has a diameter of about 3,000 miles and a mass 3 times 10 to the 20th pounds, is Saturn's largest moon. It accounts for 96% of Saturn's mass. Titan is composed of half water ice and half rocky materials. Titan is the only large lunar body with its own atmosphere. It's cold, dense, and rich in nitrogen. Titan and Earth share another thing in common, unlike other planets and moons in our solar system. This is the atmospheric pressure. Titan's atmospheric pressure is estimated at 1.4 times Earth's. The Cassini-Huygens spacecraft landed successfully on Titan on January 14, 2005, after a nearly 7-year journey and 2.1 billion mile traverse of the solar system. This was made possible by its heat shields and the proper deployment of 2 parachutes. It was able to return to Earth images and information of a quality that had never been seen before. The surface science module reveals the soil is sand-like under thin, hard crust. Titan's landscapes are similar to those on Earth, including traces of rain, erosion, river system, dry lakes, and coastal landscapes. Titan's physical processes are similar to Earth's. Titan has a more exotic material, methane. It can be found in both liquid and gaseous form on Titan's surface. Methane and hydrocarbons are deposited on the ground when it rains. Titan's atmosphere is uniform, consisting of methane and nitrogen. On the ground, cryovolcanoes are active and liquid methane can be found in rivers and lakes. On Titan's surface, which is frozen at -292 Fahrenheit and contains ice pebbles as large as cars, There are countless of them. The mission discovered Lake Ontario. It is a liquid lake of methane that is the only place outside the Earth's solar system where liquid has ever been detected at the surface. The landing itself raises questions. The probe was expected to emerge at an altitude between 30 and 40 miles. It began to emerge only 20 miles above ground level. This could indicate a change in wind direction. Sounds recorded by the probe when it landed indicate that it reached more or less a muddy surface. It is the second largest moon of Saturn, with an orbital range of 600,000 miles. It makes one orbit every 16 days. Titan, like Europa and Ganymede, is believed to have a subsurface water ocean mixed with prebioticonia that can erupt onto the surface of the moon and cause cryovolcanism. Some have suggested that Titan has life due to the presence of the ocean and prebiotic environment. Scientists have suggested that life may exist in Titan's liquid lakes of methane, but only if the water contains acetylene rather than glucose. These organisms would breathe hydrogen H2 in place of oxygen to metabolize acetylene instead of glucose. They would then exhale carbon dioxide instead. Iapetus has a radius of 1,000 miles and a mass 40 times 10 to 20 pounds. Iapetus, the third largest moon of Saturn, is located 1,800,000 miles away from Saturn. It is the furthest of all the large moons. One orbit takes 79 days. Its main hemisphere, which is black and dark, is a lot of this century glucose. Cassini, the spacecraft that was launched in 2004, has been searching for an answer to a century-old mystery. Infrared instruments discovered that debris from meteorite impact on the moon formed during around Phoebe. The astronomers who observed the moon from Earth did not discover this very fragile. Iapetus, which circulates in the vicinity of this ring, accumulates material in its front face. Iapetus's color is a result of the materials that Phoebe produced. Iapetus is Saturn's third largest moon, but it orbits far from Saturn and Titan. Iapetus, like many Saturn's other moons, especially Mimas and Rhea, has a low density, which indicates that it is made up of ellipsoidal butt and around 20% trough. Its general shape, however, is not spherical or ellipsoidal like most Saturn's bigger moons. Instead, it consists of flattened polarities and a dome-shaped waist. The disproportionate shape of the moon is also due to its unusually wide and high equatorial ridge. Iapetus, the largest moon known to science, has not reached a hydrostatic balance. Phoebe, the largest moon at a distance of significant size, is located 8 million miles from Saturn. It is 8 million miles away from Saturn. It has an irregular spherical form and orbits with a retrograde of 173. It has a radius of approximately 130 miles. The darkness is intense. Voyager 2 took the only images of Saturn before Cassini's mission in 1981. Cassini only flew over the moon once, because it was outside of its orbit on June 11, 2004. Cassini flew at a distance of 1,280 miles from Phoebe and was able to capture almost the entire surface. The speed of rotation of the moon creates a dark, cratered surface with walls up to 10 miles tall. Some craters can be as large as 50 miles across. Phoebe, a protoplanet that has characteristics similar to Pluto and formed in the Kuiper Belt during the early history of our solar system, is most likely a protoplanet. At the start of its existence, it underwent a planetary differentiation process. Its surface was damaged by impacts after cooling, which gave it its irregular shape. The planet Saturn captured it. Voyager 2, which flew over it in 1981 from a great distance, allowed us to death very deep craters which riddle its surface. See, almost traces of ejected materials are reminiscent of a sponge, the dough. Voyager 2, a satellite that flew it from a distance in 1981, gave us the opportunity to see its deep craters. The almost complete absence of ejected materials is reminiscent of the world of a sponge. It is not surprising that the deep craters on the surface of the moon are almost devoid of any traces of material ejected. This is due to its low density and high porosity. Impacting meteorites did not eject the materials, but instead compressed them. The walls of the impact craters have a shiny appearance, indicating the presence of water ice. The very low temperature -20 degrees Fahrenheit causes sublimation and accumulation of darker materials. Hyperion's low albedo is caused by the presence of methane and hydrocarbons such as carbon dioxide. Escape from Titan. Cassini-Huygens made it possible at the end 2012 to discover 10 small moons less than 6 miles in diameter. These were added to 50 or so known or discovered moons in recent years from Earth-based telescopes. Uranus does not have the best media coverage, nor is it the planet with the largest surface area. The icy gas giant is not without its curiosities. There's still much to learn about it. Uranus and Neptune are the only icy giants that exist in our solar system. It is about 2 billion miles away from our star, and in 7th place with respect to the Sun. It is composed mainly of hydrogen 83% and helium 15%, with the mantle surrounding volatile components such as water, ammonia, and methane. These volatiles are in a state between liquid and solid. These volatile components, also known as ice, are what Uranus is called. A core the size of Earth is made up of iron, nickel, silicate rocks, and other materials. Icy giants are much smaller than Jupiter or Saturn, but have the same mass as 10 to 50 Earth masses. Uranus is 14.5x more massive than Earth, but only 20% of its mass is hydrogen. Saturn and Jupiter are dominated by hydrogen, which accounts for 90% of their mass. Uranus ice stores a large part of its mass. Voyager 2, launched in 1986 by the American Space Agency to study planets outside the solar system, flew above Uranus. In 1986, it passed close to Uranus at a height of 50,000 miles in just over 5¼ hours. Voyager 2 showed a planet with little distinction visible in light but many details. Voyager 2 provided us with clues as to why Uranus' orbit is tilted. Uranus' rotation axis, unlike other planets with rotation axes that are perpendicular to its orbit around the Sun, is practically incorporated into the orbital plane. A unique feature of the solar system is that the planet rotates in its orbit and alternately displays its North Pole and South Pole. A study suggests that this inclination can be explained by the collision of a protoplanet, which was twice as large as Earth 4 billion years ago. The collision may also be responsible for the low temperature of Uranus's atmosphere. The debris of the impacting object formed a shell that would have prevented heat from the core from moving up to the upper atmosphere. Some theories propose a gradual tilting of Uranus's entire system due to the absence of a satellite that was about 100 times lighter than the planet. The question of Uranus's rotational axis tilt remains unsolved to this day. Voyager 2 discovered 10 more moons with diameters less than 100 miles. It also confirmed the existence of a similar magnetic field to Earth. The probe also revealed that the 9 rings that were discovered in 1986 were formed after the planet, not at the same time. Uranus was only visited by one space probe in 1986. Voyager 2, which studied the planet from a distance, is the source of much of the information we know about it. The study of Jupiter and Saturn was the main goal of Voyager's mission. It was only after the successful exploration of these systems that the flyby of Uranus could be accomplished. The probe studied Uranus's atmospheric structure and composition, as well as its unique climate due to its 97-degree tilt. It discovered 2 new rings by examining Uranus' 9 rings. This revealed that the rings are relatively young. Voyager 1 was unable to visit Uranus, as the study of Saturn's moon Titan was deemed a higher priority. The probe was thrown out of its planned orbit by this trajectory. Budgetary constraints have prevented several missions to Uranus since Voyager 2. Neptune is an ice giant, just like Uranus. It's also the planet furthest from the Sun. The planet is home to the most violent solar storms, which are characterized by an azure blue hue and diamond showers. Neptune is full of incredible secrets. Its composition is similar to Uranus, with a core of iron silicates and a watery methane and hydrocarbon mixture in different states, from liquid to solid. The entire planet is covered in an atmosphere made up of hydrogen, methane, and helium. Neptune's atmosphere is composed mainly of 84% hydrogen and 12% helium. It also contains traces of acetylene and ammonia. The methane absorbs wavelengths of light that are red in color, which gives Neptune its appearance. Neptune's distinct blue is closer to azure than the more common blue. Methane cannot create a tint like this. Neptune's color would be blue-green, just like Uranus. This characteristic color is therefore due to unknown chemical elements. Voyager 2 was the first space probe to visit Neptune, and it is responsible for most of our current knowledge of the planet. Once the flyby of Uranus is complete, the trajectory through the Neptunian system is finalized. This is because it is the last time Voyager 2 will pass near a planet. The way out of the planet system is not restricted, and there are several options. The team chooses a passage near the North Pole of Neptune to allow the probe to dive under the ellipse and fly by Triton. The main moon is Neptune. The main moon of Neptune. The first observations took place in March 1989, nearly 3 years after Uranus' flyby and 90 days before Neptune's close approach. The first observations were made in March 1989, 90 days before the close passage of Neptune, and nearly 3 years after Uranus' flyby. A magnetic field can be detected and measured near very fine particles, which are not visible from Earth. It is off-center from the geological center and inclined in the same way as Uranus, but with a much lower intensity. Voyager 2 distance allows it to discover 6 new moons, including Larissa, during the crossing of the Neptunian system. Due to the distance of Voyager 2, it is difficult to send out new instructions regarding these celestial bodies. Proteus is the only probe that has a diameter of 250 miles and was discovered early enough for detailed observations. In fact, it took 246 minutes for the probe signals to reach Earth. Voyager 2 mission was pre-programmed during Neptune's flyby. Voyager 2 was within 3,000 miles of the North Pole of Neptune. Neptune's atmosphere was studied, despite its less solar energy due to its distance. When moving faster than 1,000 miles per hour, manifestations such as the Great Dark Spot are observed. Studying the magnetic field enables us to calculate the rotational duration, which is 16h. The flyby provided the first accurate measurement of Neptune's mass. It was 0.5% lower than previous calculations. This new value refuted then the hypothesis that a yet-to-be-discovered planet Tex affected the orbits of Neptune and Uranus. Voyager 2 collected data very precisely on Triton's movement as it passed Triton a distance less than 25,000 miles. Scientists estimated that Triton's diameter was somewhere between 20,500 miles and 30,000. This figure was reduced to 2,000 miles by the probe. The polar regions are characterized by a very low number of craters, which can be explained by the presence of volcanism. This is evident in the form left behind by geysers. Voyager 2 detects a tenuous atmosphere that is about 1% of Earth, which was probably caused by the activity. Triton's surface temperature, which is minus 391 degrees Fahrenheit, minus 391.1 degrees Celsius, is the coldest celestial body ever measured. Triton, unlike all other large satellites in our solar system that orbit Neptune clockwise as seen above, is the only one to do so. Triton couldn't have formed from the same disk as the planet, but it must have been captured. Triton is actually a product of the Kuiper Belt, deep within the Neptune system. The temperature and pressure can both reach 12,000 degrees Fahrenheit. In such conditions, carbon from hydrocarbons on the planet could be converted into diamonds. Scientists proved this chemical reaction's feasibility in 2017. The nanodiamonds are created when the small diamonds in Neptune's intermediate layer fall toward the nucleus. It is not clear what will happen to these Neptunian jewels, whether they create a diamond envelope around the nucleus or a sea filled with hydrocarbons and diamond icebergs. You can choose. Voyager 2 departed the orbit of the Neptune planetary system at a minus 30-degree angle. The steerable platform that carried some instruments has been deactivated. However, the remaining instruments are still collecting data about the environment. Voyager 2 crossed the boundary of terminal shock at the Sun in August 2007 when it was 84 astronomical units away. It left the magnetic solar system permanently in November 2018 after leaving the Hilarious. In about 40,000 years, the probe will be heading to constellations Sagittarius the Lion and Peacock the Peacock. Voyager 2 will pass 1.7 light-years away from Ross 248, a star in the constellation Andromeda. ESA had considered for a long time a mission that would study Uranus simultaneously with Neptune, but budgetary constraints meant only one planet could be explored. Hubble observations from 2017 revealed unexpected activity on Uranus. This was the reason for Uranus' initial appeal. Triton, a Neptunian moon with active volcanoes, became the focus of scientific attention. The next large-scale mission dedicated to studying an outer planet will launch toward Neptune. It will not fly by Jupiter in order to take advantage of its gravitational pull. because it is only possible every 12 years when the planets are aligned. The next launch window will be from 2028 to 2030. An expected arrival at Neptune is around 2043. Pluto. Pluto was the 9th planet in the solar system up until 2006. Its low mass and highly inclined orbit of 17 degrees, along with its distance of almost 3 billion miles from Earth, have always made it a difficult target for space exploration. New Horizons, the probe that arrived closest to Pluto of any spacecraft on July 14, 2015, has reshuffled the deck. Pluto is a trans-Neptunian body that forms a double system when combined with Charon, its moon. Scientists had expected to discover a world that shared similar characteristics. However, the first observations far exceeded their expectations. Pluto has a young surface, almost devoid of craters. It also has unique and diverse features. Pluto is still a very active geological planet, with mountains of water ice that reach over 2 miles high. Initial images of Pluto taken by the spacecraft show a bright area at one pole and a darker band near the equator. Pluto's diameter is now measured more accurately and is estimated at around 1,500 miles. Pluto's polar cap is composed of ice containing nitrogen and methane. The dark areas are composed differently from the polar cap, with much less methane. Pluto has a variety of terrains that resemble Saturn's Iapetus moon and Neptune's Triton moon. Its surface is relatively young, with a few impact craters. Pluto's surface is covered with high mountains that reach up to 300 yards in height. Pluto's surface is covered with high mountains that reach about 300 yards in height. These peaks may be made of water ice, which is the mantle on the dwarf planet. These formations, caused by tidal force, were previously observed only on the icy satellite's gas planets. Pluto is exhibiting a completely different phenomenon, which will require further investigation to identify the exact cause. Charon's size has led scientists to rule out its influence on the tidal force. 2 possible explanations have been considered. The first is the decaying of radioactive material, such as thorium and uranium in silicates. The process is still present on Earth, but it has a negligible impact on planets of the size of Pluto after 4 billion years. Another explanation is that there could be an ocean under the icy mantle. This ocean, by losing latent heat, would cause surface movement. Pluto's atmosphere has been well known since 1988. The New Horizons instruments confirmed the high atmospheric escape rate. Solar wind may be responsible for dragging ionized dust particles out of Pluto's atmosphere. This atmosphere lacks a magnet field. New Horizons data indicates that Mars' escape rate is 500 times higher. Pluto's atmosphere constantly replenishes itself through the sublimation of materials from its surface. Pluto's size has been reduced by 3 miles over the years since its formation. Pluto's atmosphere cools and condenses as it moves away from the sun in its elliptical arc. It then falls to the Earth as ice. A photo taken by Pluto during its occupation of our star has enabled us to show the presence of haze at an altitude of up to 80 miles. In the same image, we can distinguish 2 distinct atmospheric layers. Charon, just like Pluto, has a surface that is young with few craters, but many formations. This suggests it's geologically active despite its size. Near the pole is a 6 to 10 kilometer deep long canyon, and another 5 kilometer deep canyon series of cliffs and depressions that runs from northeast to southwest over 1000 Kelvin M. These formations could have been formed by an internal process. A nearly featureless, weakly cratered surface below these formations suggests recent resurfacing. The pole is covered by a dark region called Mordor and is surrounded by reddish terrain. It is possible that the dark color of the surface is due to a thin material layer, since lighter terrain can be seen where craters can be seen. The close-up view of region on the moon near Terminator shows a very smooth surface with impact craters that are sharply defined and long cracks. These cracks are similar to lunar crevices, which were formed by the cooling and contracting of very fluid lava that had been spread across its surface. Scientists are intrigued by an isolated mountain that is located in a hollow depression. Its formation remains a mystery. This type of formation is not known to exist in the solar system. The probe detected no atmosphere. Pluto has 5 satellites, but only 2 of them have been photographed. One could take a first image, a few pixels in size, of Hydra to show its elongated form. The surface of the ice is mostly water. A few days after Nix's flyby, an image of Nix, with a pixel size that was also very large, was restored. This confirms that the small satellite is 40 kilometers long and has an elongated shape. Pluto's flyby gives us the opportunity to fine-tune the characteristics of Pluto's small moons. The spacecraft discovered that Pluto's small satellites do not rotate in sync with Pluto, unlike the majority of solar system satellites. They don't always show the same face towards the dwarf planet. Hydra, the outermost of the satellites, orbits Pluto in 38 days while rotating on itself every 10 hours. Scientists believe that despite these similarities, the small moons formed in the Pluto system. This is because they look similar to Charon and Pluto. New Horizons will cross the Kuiper Belt after the flyby. The belt extends between 30 and 55 astronomical units from the Sun. Its study is the second goal of the mission. The dwarf planet still has a lot to reveal even after it is gone. The Kuiper Belt, a belt of asteroids that orbits the Sun at a distance, is an icy belt. This belt contains the majority of dwarf planets in the solar system. Pluto and its moon are located in this belt. It starts with 30 astronomical units from the Sun and appears to end at 55 astronomical units. We find a less densely populated area beyond that. However, there are still dwarf worlds, such as Immerse and Sedna. Only 2 smaller objects have been explored in the Kuiper Belt. We have captured some images of objects that are relatively close thanks to the New Horizons probe. Orion, the quasi-satellite Pluto, was able to provide us with some details, such as its rotational period, in November 2015 and April 2016. It was located 68 million miles away at the time. At the time of the launch in 2006, there was no trans-Neptunian object within the range of New Horizons in the Kuiper Belt. The spacecraft's propellant would be limited after crossing Pluto. Mission officials are relying on discoveries made in the decade that will pass between the launch of the probe and the corrections to the trajectory needed to guide it to the second target, the Kuiper Belt. After 8 years of astronomical research, the Kuiper Belt has not been discovered. The deadline to find exploitable target was the summer of 2014 for a rendezvous. The orbit of the object is required to be known, as the probe is to make 2 observations every year. First, the first observation should have been made in the summer of 2014 in order to guide the probe to its second target after Pluto's flyby in July 2015. It is difficult to find a trans-Neptunian object within the range of the spacecraft because there are so few objects in the Kuiper Belt. Around 1,000 objects were found in an enormous volume of space. They are difficult to detect due to their small size and distance. Between 2011 and 2013, despite the fact that they were separated by only a few tens of astronomical units, significant resources were spent to find a target. A massive observing campaign using the most powerful telescopes on Earth was carried out. The Kuiper Belt was discovered to contain 52 new objects, but none of them were within the New Horizons. The maneuver required by the closest target would have used more propellant than was available on the probe. In October 2014, New Horizons revealed that, given its fuel reserves, it was certain to fly past at least one target. The study of 2 other possible targets that are similar in size and distance, but close to each other, continues. The same procedure was followed for collecting data on the Kuiper system as it was with the plutonium. The flyby course is more challenging because of the limited precision in the orbit. Scientists would need to make corrections late on the probe's trajectory. On August 16, 2018, the Kuiper object appeared for the first in images captured by the camera of the spacecraft. New Horizons, while 100 miles away from its target on the 1st of July 2019, flew by Eric Goff at a distance and speed of 2,000 miles. The Earth was 41 billion miles from the Sun at the time of flyby. The first data was received after 4 hours. During this short passage, 6.25 gigabytes of data were recorded. We noticed that there are fewer objects at about 55 astronomical unit distance from the Sun. This area is called the Kuiper Cliff. This area may mark the outermost limit of the belt. Beyond that point, the space is still not empty. There are other objects in the distant region known as the sparse disk, such as dwarf planets, like Immerse, which is roughly the same size as Pluto, and Sedna. Immerse is currently about 95 astronomical units from the Sun. However, Its orbit will take it back to the Kuiper Belt a few hundred years later before it leaves. Sedna is a detached object. Sedna has currently located 85 astronomical units from the Sun. Around 2080 it will pass 76 astronomical units, then move to a distance of 950 astronomical units from the Sun. Even smaller objects can reach 3,000 astronomical units. The Oort cloud is made up of millions of comets and extends beyond that to 20,000 astronomical units. The Oort cloud has never been seen because it is so far away. However, its existence is almost guaranteed because some comets are very distant. The Oort cloud may extend to 100,000 astronomical units, but we do not know its end. This is more than a light year, so you can get an idea of how big the universe is. According to the first photo in low resolution received the day following the flyby, this transmission took around 20 months. It lasted until the end of September 2020. Eric North is a collection of spheres of different sizes welded together in the form of a snowman. This is an example of a binary object with a contact that has been preserved exceptionally well. The impact must have occurred at a very low speed, perhaps a few miles per hour. These binary comets are common and share the same origins as Erica. The body measures approximately 20 miles by 9 miles. The two elements are currently known as Ultima for the bigger element and Truly for the smaller. The rotation period measured just before the flyby was 15 hours. The surface appears to be devoid of large craters. The surface is a similar reddish hue to the North Pole cap. This is likely due to the presence of organic polymer materials. These features indicate that the Kuiper Belt object formed at the beginning of solar system formation and retained its original properties. New Horizons could continue its mission until 2025. By then, the spacecraft should have reached a distance of 50 to 60 astronomical units or the outer edge Kuiper Belt. There are scattered objects beyond that, whose density makes flybys unlikely. The mission project team is hoping to find a second target for the spacecraft within the Kuiper Belt. The discovery of Erica could be difficult given the significant resources that were mobilized in order to locate her. The probe could still visit the site if it detected the object. It will analyze the images. It will take and detect an object whose luminosity is too low to be detected by terrestrial telescopes. This new target will need to be found in the next couple of years before the spacecraft departs the dense Kuiper Belt in January 2018. New Horizons, Voyager, and New Horizons teams met in order to lay the foundation for a possible collaboration on observing the heliosphere. The instruments and the positions of all three spacecraft Voyager 1, 2, and New Horizon complement each other until at least 2025 and possibly 2027, when the remaining energy in the Voyager probes is no longer sufficient to keep them operational. The remaining power of the spacecraft by 2032, when New Horizons is located at 82 astronomical units, will be 150 watts. This will be the minimum needed to keep the spacecraft operational, although it may be possible to push this theoretical limit. By the time the probe reaches 120 astronomical unit distance, it will not be functional. What lies beyond the Kuiper Belt then? It's important to note that, due to the distance, an object will be harder to detect the farther it is from the Sun.